Hi, everybody. In this part of the lecture, I'm going to talk about assumptions. We've discussed assumptions in different times, variety of ways, and some of this, couple of students expressed a little bit of confusion. Is like, what to look for, what, when, and etc. So let me take step by step. So, for example, let's say you're trying to assess normality. Okay. The first things first, this is the same HATCO example. I'm going to use this as the initial, let me do this, like for a simple regression or all the assumptions. Like I want to check normality. So how do you do it? Go to Analyze, Descriptive Statistics, Explore. Analyze Descriptive Statistics and Explore. And I already just did it, as you can imagine. So I picked up the 7 independent variables. Remember, they should be normally distributed. They should be metric variables. Okay, and display should be both. Okay, statistics, descriptives. You can select outliers if you want. And in plots, normally this is by default stem and leaf. Take it out. Select histogram and normality plot with tests. Okay, and press OK. So when you do that, you'll get variety of graphs and multiple tables. So first, what you're supposed to look at is just to make sure that your data is not chaotic or skewness, meaning it is not left-centered or right-centered or above the normal distribution curve, like above or below. Okay, so how do we do it? So in this table, you'll see the mean value. Here is the mean value, lower bound, upper bound, and 5% trim mean. And then you'll have the minimum value and the maximum value. Minimum value is pretty important. 0, if, you should use it when you are dealing with skewness data. I'll send you some links for YouTube videos, how to deal with them. Check it out, or go online and read somewhere. But in this case, how do you deal with skewness? The skewness is, there are depends on what book you see. There are a variety of ways people explain how to deal with, how to understand skewness and kurtosis. Now, simply speaking, my suggestion is consider both the values, the actual statistics and standard error. Now, how do we do it? I'm just going to use the PowerPoint. Bear with me for a second. Okay. So in this case, the way to determine statistics is your z-value. You need to calculate a z-value. Okay, how do you calculate a z-value? Z-value is nothing but statistic divided by standard error. Okay, so in this case, your statistic is minus 0.085 divided by 0.241. Okay, which will give you, let me use my calculator, it makes my life easy, 0.085 divided by 0.241. It will give you a value of minus 0.35. Now, what is a benchmark? This value, whatever z-value you're going to get, whatever z-value you're going to get should be in the range of minus 1.96 to plus 1.96, 95% confidence interval. That's pretty much it is. It's nothing different than that. The same thing applies for kurtosis as well. This value divided by this should be between minus 1.96 to plus 1.96. Unfortunately, you have to do this by hand. that is your first step. So to determine if the particular distribution is skew or chaotic. Okay. Another rule of thumb is which value should be, between -1 and +1. This value should be -1 and +1. So if you just say this, these two fall in the range, so they are not skew or chaotic. These two fall in the range. Even if you divide this by this, you should not get more than 1.96. Okay. And -0.289 divided by 2.241 and -1.073 divided by 0.478. Now here you will get over 2. Okay. Just so that you know, 1.103 divided by 0.478. 2.45. So this is about 2.45. That means this data is chaotic, and depending on other issues, we're going to decide what to do with that. By the way, that is price flexibility. Okay. And this is in good shape. This is in good shape. Here we have no, again, this is a little bit skew. Salesforce image, 0.493 divided by 0.241, 0.493 divided by 0.241, 2.04. Again, it's pretty close to 1.96. I would say let it go, but if you're adamantly want to change it, you can certainly consider it. And this is fine. So in essence, except for Salesforce image, and which is a little bit skew, and price flexibility, which is a little bit chaotic, everything else looks fine. The next thing you have to see is the test for normality table. And this is of particular importance. It's pretty straightforward. The significance of Shapiro-Wilk. Don't use Kolmogorov-Smirnov. It's quite a few people say it's kind of useless, so don't use it. Shapiro-Wilk test. Now this value should be less than 0.05. Okay, I repeat, this value should be greater than 0.05. So in essence, you'll see price level, price flexibility, and sales force and also product quality are not normal. I repeat, these 4 variables are not normal. So if you indeed want to use it, please use the transformation that I showed you in one of the slides and transform those 4 variables. Okay, that would be my immediate suggestion. Having said that, just having a look at it, now delivery speed, you can see it's pretty okay. It's a little bit skewed on this side. Okay, now if you want to actually have a graph on this, so you can double click on it. You can double click on it and click on the graphs here, show distribution curve, normal curve, and okay. And you can see a curve. It's not bad at all, honestly speaking. So you can never expect a perfectly normal distribution. If you're actually expecting, you're daydreaming. Okay, honestly. And now this is, I would consider, quite a few people consider this is very important. If your data is hugging this line along, you are in pretty decent shape because it's the top line image of it. So you're in good shape. And this determined normal QQ plot, ignore it when you're looking at normal distribution, because this is nothing but a different view of the simple QQ plot. In essence, the explanation you can say is like, if this is your mean line and this is a difference, this minus this is this distance. Okay, if it is 0.2, 0.4, and this is about 2.6, and this is that value. As you can see, this is the farthest from the line, and that's why this is the farthest. And you can see that this is a little bit farther from here, so you'll see the last point is farther from that. Okay, so it is the same graph. If you get, my suggestion is look at this line. If that is a straight line, you should be in a good shape. Okay, now the box plot could be considered to find outliers. If you have data above this line or below this line, that means there are some outliers. Having said that, I will not suggest you to use this because this is a 95% curve. And for outliers, many times we actually look at 100%, 99% the confidence interval for finding outliers. So I will not suggest you to use this that much. Instead, use the Mahalanobis distance thing that I've mentioned a few times. Okay. Now, this is what? Price level. Price flexibility. Remember, this is what came out to be a little bit chaotic. Let's see what exactly does it mean by that. And this is what it is. It's the data is above. Okay. Let me see. 1 second. Is it negative chaotic or positive chaotic? Yeah, it's a negative chaotic. Okay. And another one that was a little bit of problem was the Salesforce image, right? You select this instead of scrolling up and down like baby. So this came out to be a little bit skew if you happen to remember, but look at the data. It looks pretty smooth. In fact, it's not that much of a problem. I really don't believe you should do anything to this. It actually came out to be a little bit much more chaotic than otherwise. But again, you can certainly transform and check it out how things are playing out. Okay, and you can see why it is a little bit on the offside. It's pretty decently hugging, I would say. I wouldn't change much in it. Okay. Overall, I think this data is fine, except for a few instances. You can certainly transform and make it a point that you are not questioned in a business setting. Okay. Again, I repeat whatever I just discussed. What I did is I checked on the normality of these 7 variables. Okay. In fact, normality and linearity to a certain extent. What I looked at is skewness. Well, all you have to determine is the statistics divided by this should be in the range of minus 1.96 to plus 1.96. Okay. Minus 1.96 to plus 1.96. And the same applies to chaotic. There are 2 variables which are a little bit off. Other than that, everything else was fine. Okay. And then we looked at test for normality. These 4 variables, 0.017, 0.001, 0.007, and 0.028. These are the values which are less than 0.05. That means these 4 values are not normal as per the Shapiro-Wilk test. Now, I told you, after that, after looking at the graph, I looked at this QQ plot, which is kind of determines the linearity as well. It's pretty much hugging to the plot, all the graphs. So I would not do too much to this, except for a few variables here and there. I think they're pretty much hugging to the plot. And so I generally wouldn't do anything to this data set, okay, honestly speaking. But again, it's your justification. You need to sell that, saying that considering the QQ plot, the histograms, all the statistics, we determine that we don't have to do it. But if you happen to do it, nobody's going to question you otherwise as well. Okay, this is one of those gray areas where you have to use your judgment. Now, having said that, there is another reason why I'm saying you don't have to do much about this significance of Shapiro-Wilk. The Shapiro-Wilk is too sensitive to smaller sample sizes, like 100. The problem with that is, even if one variable, even if there are, let me rephrase it. Shapiro-Wilk is too sensitive to sample sizes. For example, let me tell you what I mean by that. Like price level, it came out to be not normal as per this, right? Now let's look at price level. Now in price level, the frequency of this particular value is pretty minimal. You see, the frequency of this particular value is pretty minimal. It's like probably 2, and the frequency of 2. And because of lower frequencies under each possible value, you tend to get insignificant results for normality checking. That's the reason when you have smaller sample sizes, normal distributions are pretty difficult. As you can see, you always say you need a minimum of 30 to actually check for a normal distribution. But in this case, I wouldn't do much, meaning because the proportion, the chance of having, because of the frequency, possible frequency under each possible value is not that high, your Shapiro-Wilk is too sensitive. Hence, I would not use a Shapiro-Wilk as much. Having said that, guys, this is one of those things where I'm not definitively telling you do this or do that, but please use your judgment considering all the options that I just gave. Thank you. Oh, but why am I saying thank you? Sorry, that's for normality. Now, coming to the other assumptions, I would actually you test them using a different framework. I'll use regression linear. Okay, you will see this in other. You will see this when in logistic regression also. So what I'm going to do is I'm going to use one of the dependent variable. You could pick anything, doesn't matter. Okay, statistics, do not select estimates or model fit that are normal. Check on collinearity diagnostics because you are looking at multi-collinearity, outliers, and everything. Outliers beyond 3.3 standard deviations. If you indeed want to eliminate at 95%, you have to name it as 1.96 standard deviations. Don't do that. You will lose a lot of data set. Okay. Covariance matrix so that it will actually give you correlations between all the values. Okay. Plots, Z residual and Z predictive as always. And standardized residual plots as well. Okay, save. All I'm saying is Mahalanobis is distance. Blah, 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 distance. Okay, fine. Now in this case, I'm looking at VIF factor. By the way, I took out service. You can certainly check it out with service. It's much messier. Actually, why don't I just do it? Analyze regression linear. This kind of sounds repetition if you happen to see logistic before this. Okay. So the moment I put service, your VIF factor, various inflation factor, which is supposed to be less than 10, 3 values are over 10. Okay, that clearly shows that it's pretty messier, right? And you really don't have to dig deeper. You just eliminate one of these 3 variables because, and normally, as I always suggest, you take the worst player out, right? So service should be out. Why is service so bad? Look at the correlations between other variables. Service and price level is 0.975. That is next to insane. Okay, and 978 delivery speed. That means it's so highly related to these two that it's messing up the whole chart. Okay, and you can see delivery speed and price level, which are the 2 highest correlations to service. They have the very bad inflation factor as well. That's the reason you should take one of them out. I would personally take service out. So I'm rerunning this linear, take the service out and press OK. The moment you take that one out, your VIF is pretty damn good. Everything is less than 10. Next thing, look at the correlation matrix, except for one correlation matrix, which is 0.769. Everything else is fine. Okay, you should try to eliminate variables which have a correlation of over 0.7, but in this case, just one of all. So I'll let it go. Okay, then residual statistics. I'm looking at Mahalanobis distance in order to identify outliers, just to see if there are indeed any outliers. So the maximum value of Mahalanobis distance is 13.746. Now, how do I get the critical value? I would suggest you go to Google. Okay, go to Google, type Mahalanobis distance critical value Wikiversity, and the first link will give you Mahalanobis distance from degrees of freedom to 10. Okay, now you can ask me what is the difference between this and the individual outlier? So this is called multivariate outlier. just because you have an outlier for one particular case does not make that particular case bad. Okay, it certainly depends on how that particular outlier depends on other responses, right? For example, if everybody in my group makes $50,000 and above, and I am the only person who makes $25,000 per year, and I'm an outlier, right? But having said that, there are other variables. Okay, what did make me make only $25,000? It might be the amount of work I put in. Okay, if that is indeed related well with my 25,000, then it is technically not an outlier. It's probably helping us better in the long term analysis. So that's the reason I don't take it out. So this is a multivariate normal. So what is the degrees of freedom? The degrees of freedom in this case is there are 5 variables. There are 6 variables, right? Yeah, there are 6 variables. So I would consider 6 is my degrees of freedom. There are different schools of thought. Some people say n minus 1. That means 6 minus 1. You should consider 5 as your degrees of freedom. When you're doing a multivariate normality with standard error as in your equation, I would suggest you to use just n as your degrees of freedom. Generally, you wouldn't go wrong. Just use n for the discussion. There are a lot more advanced way to analyze these degrees of freedom. We will touch it next semester. But at this point of time, consider just n as your degrees of freedom. Okay. So in this case, the critical value is 22.46 because we have 6 variables, and the maximum honorable distance is 13.746. So we have nothing to worry about. Okay. Now the charts, this is a QQ plot. Okay. I would say it's pretty damn good. Okay. And the satisfaction level is a metric variable. That means everything should be like a rectangle. It's in a good shape. And that concludes your other assumptions as well. Thank you.